Good morning, everyone. I hope everybody is fine. And today, after a long break, we are here back again. And before the break, we have started with the chapter number 13, volume and surface area, where we have discussed in 2 lectures, I guess, the formulas. And we have started with the first exercise and 4 questions we have done. So today we are going to start with question number 5 of exercise 13.1. Just starting in a minute. As you all know that this chapter contains 8 exercises and it will take time, and easily this month will be taken by this chapter, and we have to start with the revision also, so we'll try to complete this chapter in this month. Solution. Yeah, good morning to the rest of the students, those who have come now. See, this cubical box has edge. So one of the information is given here that there is a cubical box, a box in the shape of a cube. Fine. And there is one more cuboidal box in the shape of a cuboid. One more cuboidal box where length, breadth, height is also given. And we have to find the lateral surface area of both, and we have to find which has greater lateral surface area and which box has smaller total surface area. So let us start with this. It is very easy, simple. We have to apply the formulas. Rest is all easy. Right side of cubical box is equal to 10 centimeter, and length, breadth, and height of cuboidal box (12.5 centimeter), and breadth, then height also. Just make a note of this. 12.5, 10, and 8 centimeter. These are the dimensions given of cuboid. Now, the first part where we have to calculate the lateral surface area of both. So, LSA of cubical box, lateral surface area of cube is 4a square. That is 4 into a, that is 10 square. So 4 into 100, that is 400 centimeter square. Then LSA of cuboidal box, that is twice of L plus B into H, and twice of L 12.5 plus 10 into H. H is 8. So twice of 22.5 into 8, that is 45 into 8, and finally the answer is 360 centimeter square. Here, now we can easily say that whose LSA is greater? Yeah, cubical box has greater LSA. Yes. So just let us write that cubical box has greater LSA by how much? Just subtract both. 400 minus 360, that is 40 centimeter square. I hope it is clear. Simple application of formulas to take out the answer. Okay, for example, LSA of cubical box, the formula for LSA of cube is 4a square. The formula for LSA of cuboid is 2l plus b into h. Okay, just apply these formulas, you will get these two answers, 400 and 600. Sorry, 406, 360. So which has greater LSA, cube or cuboid? Cube has greater LSA here. So we'll write cubical box has greater LSA by 40 centimeter square. Now the second part. In second part, they are asking which has smaller TSA. So let us calculate now TSA. TSA of cubical box, then TSA of cuboidal box. TSA of cubical box, that is 6a square. Then 6 is to 6 into 10 square, that is 600 centimeter square. Then TSA of cuboidal, twice of LB plus BH plus LH. Then put all the values here. 12.5 into 10 plus 10 into 8 plus 12.5 into 8. So that is 125 plus 80 plus 100. 2 multiplied by 305, and that is 610 centimeter square. With this, we can say that TSA of cuboidal box is greater. TSA of cuboidal sorry, we have to write regarding smaller box. So TSA of cubical box is smaller by 610 minus 600, that is 10 centimeter square. Make a note of this. So this is question number 5. Moving to the next. Note it down. Now read out the next question. A small indoor greenhouse is made entirely of glass panes, including base, held together with tape. Now, maybe a student has made this indoor greenhouse, which is just shaped like something like this. And it is made up of completely glass. And the base is also made, means the base is also made with this glass. It is written here including base, means all the 6 sides are covered with all the 6 faces are covered with glass. Then only greenhouse will be possible. Okay. And it is held together with tape, and the student has made this uh, greenhouse, indoor greenhouse, with the help of glass panes, and all the glasses he has attached with the help of tape. And see, for example, tape he has put here, 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 like this. Taping he has done on every side. These are all the 12 sides where he has applied the tape. Now, what is the area of the glass? It's an air length, breadth, and height of glass. This indoor greenhouse. This is given 30 centimeter. The same way, these are given 25 centimeter. And this is given 25 again. Now, in first, it is asked area of the glass. What do you mean by area of glass here? It is CSA, this CSA. What is this? Yes, it is TSA. You are correct. So area of glass here means the glass is used in every face, means all the 6 faces are covered with glass. So that's why here we have to apply TSA. That is twice of LB plus PH plus LH. Now twice of LB, 30 into 25 plus 25 into 25 plus 30 into 25. So it is 750 plus 625 plus 750, twice of this, and it will be equals to 2125 into 2, that is equals to 4250 centimeter square. This is the answer of the first point. Now second, how much of tape is needed for all the 12 edges? I have told you the perimeter of cuboid in the formulas. The same formula you have to apply here. How many edges are there? There are 12 edges in this. Simple. And out of this 12 edges, 4 are length, 4 breadth, and 4 height. Yes. So let us write length of tape required is equals to 4 times of L plus B plus H. 4 times of L, that is 30, plus 25 plus 25, 4 multiplied by 80 that is 320 centimeter. Is it clear to all? If you have any kind of confusion in these questions, you can ask, sir, why we are calculating TSA? What is the reason behind this? How we'll get to know that we have to calculate CSA or TSA? When to calculate volume? How we get to know that we have to use here this formula, that formula? Every question, if it comes like this in your mind, you should ask it. Okay. If it is clear, then it is very good. This is a complete solution. As it is just the length, so that's why it is only in centimeter, not centimeter square or centimeter cube. Note it down, then we'll move to the next question. Now the next question, number 7. Shanti Sweets stall was placing an order for making cardboard boxes for packing their sweets. So there is a stall named Shanti Sweets, and they want to just pack their sweets. So they want two sizes, two types of boxes. Means two types of boxes of two sizes, different sizes. It is written 2 sizes of boxes were required, and the bigger box has the dimension 25, 20, and 5 centimeter length, breadth, height, and the smaller box has the dimension 15, 12, and 5 centimeter. For all the overlaps, 5% of the total surface area is required extra. Overlaps, are you clear with this? For example, how to make that? Leave it. See, you've seen a sweet box I'm trying to make in the same way, or let me make it like this. Wait. Oh, easy if I'll take the image. Just wait. So here we have a sweet box. See this, in this sweet box, this part, what I'm talking about, this part, this is covering the box 2 times. For example, this colorful part is there under this black part. Yes, no? So this is overlap. What is this? Overlapping of box in all the sides. Clear? And for that, no, it is written for all the overlaps, 5% of total surface area is required extra. Means because of these overlaps, because they have to close the box. So how box will get closed? Because we need this extra surface area. Yes, no, this extra cover is required. I am not talking about this part. This is all correct. But this is overlapping of the box. the box on box. Okay, so that's why 5% TSA will be required extra. And if the cost of the cardboard is rupees 4 plus for 1000 centimeter square, what is the cost of cardboard? So we'll talk about this later. What is the cost of cardboard? First of all, we should know how much cardboard we required. Okay, and how many cardboard they're asking for? 250 boxes of each kind. See, one is the bigger box and one is the smaller box. Bigger box also we want 250 boxes, and smaller boxes also we want 250 boxes. Clear? Yeah, and at the end they are saying that total surface area, whatever is required in total surface area, in total surface area, 5% will be required extra. So this I'll talk about later, how this 5% we have to deal with. Rest, let us start with the simple calculations regarding total surface area of these boxes. Right, length, breadth and height of bigger box is 25, 20 and 5 centimeter. And in the same manner, we have length, breadth and height of smaller box that is 15 centimeter, 12 centimeter and 5 centimeter. Okay, so let us calculate first of all TSA of one bigger box. That is twice of TSA of bigger box, twice of LB plus BH plus LH. Twice of LB. L is 25, B is 20, plus B is 20 and H is 5, plus L is 25 and H is 5. So it is 500 plus 100 plus 125, and at last it is 725 multiplied by 2, it is 1450 centimeter square. This is TSA of one bigger box. But how many bigger boxes are required? 250 bigger boxes are required. So TSA of 250 bigger boxes. So 250 multiplied by 1450. Okay, so that is multiply them. Three 62500 centimeter square. Okay, so this is TSA of 250 bigger boxes. In the same way, let us calculate TSA of one smaller box. Now length, breadth, height, we have to consider these three, 15, 12 and 5. So twice of LB plus BH plus LH. So that is twice of 15 multiplied by 12 plus 12 into 5 plus 15 into 5 is 180 plus 60 plus 75 twice of, then 240 and 75, 315 multiplied by 2, that is 630 centimeter square. Now TSA of 250 smaller box, 250 smaller boxes, then 630 multiplied by 250, I think 157500. After the multiplication you'll get this 157500 centimeter square. Now let us read out the question again. See, cost of cardboard we have to calculate, and that is based on the area, because we should know how much cardboard is required. First of all, we know that how many boxes are required, 250 boxes of this and 250 boxes of this, and how much area it contains. 250 boxes of bigger means 250 bigger boxes contains this much area, let me highlight, and 250 smaller boxes contains this much area. Fine, so let us calculate TSA of both boxes. Both size of boxes, that is 36, add them both, 362500 plus 157500. By adding them, 520000 centimeter square. Okay, now TSA again is 52000. This is TSA, plus it is written here that 5% of the TSA is required extra, means 5% of TSA is required extra. What is TSA? TSA is 520000. We have to calculate here 5% of TSA, that is 520000. So in the TSA, we have to add 5% of this TSA only, because this TSA is not the actual total surface area, because it is written here that 5% is required extra because of some cuttings and margins, or you can say overlapping. I have shown you the box, no? There was some overlapping. Because of that overlapping, 5% of the surface area is required extra. So let us write here 5% of 520000, 2020 cancels out, and here we go 520000 546000 I have put extra. This much centimeter square. This is the final total surface area in this question. This much cardboard is required extra. So cost of cardboard. Now what is the rate of this cardboard? It is given here, rupees 4 for 1000 centimeter square. Rupees 4 for 1000 centimeter square, multiplied by 546. Now cut these 3 and 3 zeros, multiply 5, 4, 6 and 4. 2184 is the cost. This is the way of doing this question. So little lengthy question. This much we have solved. Note it down, be quick. Then we'll do one more question. One minute I am giving you to note it down. Then we'll begin the last question of this exercise. This is the first part of the question. Those who've not written. Dakshveer, might be you have done by any other method. There are many methods of solving this question. You have to check this, the final 546000. Is it matching with your answer? The final TSA after the 5% addition. This is the correct answer. Okay. Now moving on to the next. Question number 8. Parveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin that covers all the 4 sides. Tarpaulin means it's a type of cloth that is used to cover all the 4 sides. See, if you want to make a car cover, then obviously you will make the cover for covering the 4 sides of the car and the top of the car. Obviously, but obviously you're not going to cover the bottom of the car because you're not going to lift up the car to keep the cover below the car. So that's why, so it is very clear that if you are going to make the cover for the car, then 4 sides and top of the car will include. Assuming that stitching margins are very small and therefore negligible. So we have not to think on the wastage in stitching and margins. So how much tarpaulin will be required to make the shelter of height this and length breadth this? Just write length, breadth and height of shelter which is required. Length is 4 meter, breadth is 3 meter and height is 2.5 meter. Now tarpaulin required is equals to twice of L plus B into S. This is area of 4 walls plus top. We have to apply this formula, area of 4 walls plus top, that is LB. So twice of L plus B, 4 plus 3 into 2.5 plus 4 into 3. So twice of 7 into 2.5 plus 12. It is 35 plus 12, which is 47 meter square over. This is the only solution of this question. Note it down. Please please, sir, please show question number 7 again. Okay. Dakshvi, you can have a look at this. Wait, we make it easy for you. Sandra is asking, sir, can we use 2 LB plus BH plus LH minus LB also in this question? Yes, you can use, but this is a lengthier way of doing it. It includes more calculation because you are calculating the full area, then you're subtracting 1. Okay, but there is no need to calculate full. This is correct. No marks will be deducted. It is correct. Okay. Yeah. Otherwise, with the help of the formula that we have written in our notebook, that is area of 4 volts plus top. Make a note of this. So only 1.5 minutes are left. So the class gets over now. Yeah, Dakshvir, bye. Take care, everyone. Tomorrow we'll begin with the next exercise. And this chapter will get over by 3rd or 4th of December, I guess. Yeah, write it, Sneh. The class will automatically get over.